Welcome. This video explores the idea of scope and functions and has some debugging tips for working with them. So recall that the main way to get information into a function is via the parameters. I want to call the max function. I want to pass it two numbers to work with. So I have parameters num1 and num2 in the function that are going to basically be like variables for the max function, but variables that we can set from outside the function. That's what parameters are. Local variables that we can set from outside the function before we call it. And then we may or may not have additional local variables that we create as we're doing calculations. The scope of a function, the variables that are available, is limited to those parameters and whatever local variables we declare. Unlike when you're in, say, main function and you go into a nested scope for an if or else block and you retain the existing variables, when we call a function, I'm in main and I, j, and k exist, and then I call function max. As we switch into this new function, we basically reset the list of variables that are in scope. And so now I and j are not. If I try and use them, it's an error. If I try and use k, it's an error. The only things I can talk about are num1, num2, and result. So the process this works by is what's called a stack frame. We're going along, we're in main, and there's space on what's called the stack. That's the portion of memory that the compiler is using to manage our variables for us. And I have I and j and k. And then I call the max function, and what that does is creates a new stack frame, a new region of memory where the variables for this new function, max, is going to have num1, num2, and result. So those are laid out in a stack frame, some space to store them. Values from main are copied in to those parameters to initialize them. And then we do our work in the stack frame. We're limited to the stack frame. The max function can't reach back into the main function and use its variables. And when we're done, we return something out, and that's how we get information back to the previous stack frame. Our stack frame for max goes away. When we're done with this function, it disappears, and then we're back to the next function on the call stack. We're working in main, and that's where we've returned to in our code. We've bounced back to here, and now we're working with I, j, and k again. Now, to get an idea of what this looks like, there's a handy tool called Python Tutor where we can watch code run, and it actually illustrates what's in the stack. So this code is going to check if x, y, and z are all close enough to each other, if each pair is close enough. And that means just off by 1 or 0. That's close enough. The close enough function is right here. It calls myAbsolute to make sure that the difference of the two numbers is positive, and then decides, are they close enough? So let's go ahead and watch this code run. I'm going to start it up. So we start main, and the stack frame for main is laid out. X, Y, and Z, we have space for those. We start running. They get initialized. And now we get to the first call to close enough. And we're going to pass in x and y, the 4 and 3. And that function called to close enough is going to bounce us up to here. Our new stack frame only needs space for two variables, num1 and num2. There's, two parameters, and then we're going to have int difference. So we lay those out. We add space for difference. We initialize num1 and num2 with the values that were passed in, x and y for main. Now we're going along, we calculate our difference, and we call myAbsolute value, and I pass in the difference. So that's going to bounce us up to here, to the myAbsolute value function. So here's another stack frame to do this work in. It's got space for number. We're passing 1 in from down here. So number is going to be set to 1. We do our work, and we return our answer. And as we return our answer, we bounce back to where we were. Right here, we store the answer, which was 1, into difference, and that my absolute value stack frame disappears. And now we're just left with the close enough one. And as we finish up here and we decide that yes, those are close enough and we return true, the close enough stack frame disappears and we get back to main. And we take that answer and we use it to print out x and y are close, 1, true. Yes, they are. If we now execute close enough again and we pass in different values, we're going to build the same stack frames back up. So great, we've got a call close enough. We make a new stack frame and it's starting over. It doesn't remember what the values were from last time. We're starting with a fresh clean slate. We're passing in x and z, 4 and 5. So great, those are what we're using in this version of the function. Difference is -1. We pass off to my absolute value. Again, that's going to create another stack frame here where my absolute value does its work. Starting with -1, it returns its answer, which gets us back to where we called it from here in close enough. And we store that answer as the difference. And now we're ready to finish running close enough, which will get us back to main. And then when we return out of here, the close enough stack frame will disappear. So it's this process of building up stack frames as we go into functions, then tearing it back down as we come out, and reusing the memory space here over and over and over to do different jobs. Now we can't see the process quite as clearly in Qt Creator using the debugger, but we can still use the debugger to walk into different places. So I've got a breakpoint here. I'm going to go ahead and fire up the debugger. And I can see that X, Y, and Z have already been set. I'm on this line that calls close enough. Down here, I've got two different options: step over, F10, or step into, F11. This first time, I'm going to hit step into. And what that does is it takes me off to wherever this function, whatever functions are in here, close enough, it's going to take me into that function so I can watch it run. And difference equals num1 minus num2. There's no functions there, so step into and step over do the same thing. Okay, we're going to calculate difference, and you can see my local variables now don't include what was in main, only what is in close enough. If I want to see the stack frame for main, I can use this pane of the debugger. I can see right now I'm in close enough at line 18. I came here from main, line 31. So now I'm looking at where I was in main. That got me to here. I'm going to step into this one, so that'll take me up to the myAbsoluteValue function to watch it run. And great. Now I'm in myAbsoluteValue. That's only the variable number exists, but I can see that I came from close enough. And this is what things looked like in close enough when I called myAbsolute. I can go back to main. As I finish running this function, we get back to close enough. Now my absolute's gone. It's not part of the call stack. We're just in close enough. We're looking at what's going on there. I finish this function up. We return back to main. And now main is the only function on the call stack. If I hit step over, it's going to run this entire line of code and just skip over whatever is happening inside that function close enough. And so I just see the final output of that line, and I don't watch all the code in between run. If there's a breakpoint somewhere in here, so let me put a breakpoint right there, then even if I hit step over, it would try and blast through this entire line of code, but it's going to hit that breakpoint along the way and stop. So my absolute value, I can see I'm on line 8. I can see that currently number is -2. I can go figure out where did we come from. We came from line 18 of close enough. And here's what the variables there looked like. I can figure out where did that come from. I came from main line 33 from this call where 3 and 5 got passed in, Y and Z. And that's why num1 and num2 are 3 and 5. And that calculated a difference of -2, which is why up here number is -2. So we can explore the whole call stack, all the functions that are currently busy running, the one that's currently active, and all the ones that are paused, kind of waiting for results to come back to them, and look at the state of all of those. But the key difference there is using the step into versus the step over to just skip over a line and run it, but not look at what's happening under the hood, versus step into, which will actually take us in. This last button, step out, if we're in a function and decide, I don't want to watch the rest of this code in my absolute value run, step out will just blast me out of that function without watching the rest of it. Okay, I'm done here and close enough. I just want to get back to main. I hit step out. It finishes running the code. It just doesn't show me step by step. Now, before we finish talking about scope, there's one other thing you should be aware of, and that's global scope. If we declare a variable outside of any functions, it has what's called global scope. So in this program, if I make int a, I can access that a variable from my absolute value, from close enough, from main, from anywhere I want. All right, its scope is not restricted to any functions. In general, this is considered a really bad idea. It's considered a really bad idea because what it means is that any function can access this piece of information, which means if we're trying to debug our program and we see that a has got some weird value, I have no idea of who set that value or when or why. It's really hard to reason about things that just mysteriously change and everyone's making changes too. It's much easier to reason about kind of this clear mechanism of I pass values into the function and I get an answer back from it. And I'm not worried about these weird side effects and that this max function is going to go secretly change some variable that is in the global scope that then I can go see too. Basically, in this class, you should not ever have variables at the global scope. Unless you hear otherwise, I give you some very good reason why we're doing it. You should not use global variables. It's okay to have a global constant. So if you're going to declare something like pi and you want to use it all over in your program, it's perfectly acceptable to do something like this, as long as you make a const. All right, and that's what's going to make sure that pi never changes. And so now I'm not worried about the weird side effects of functions changing this value. It just means that in any of these functions, I can use pi, and it's always going to be the same thing. So okay to have a constant declared at the global scope, not okay to have a regular variable.